Hello, everyone. I hope everyone has had a great experience at PASS Summit 2021. This session is titled SQL Server 2022 Storage Engine Capabilities, specifically focused on the new storage engine features in SQL Server 2022. We're going to focus on many of the storage improvements around performance and scalability, such as system page latch, concurrency improvements, advances in capacity management and maintenance, and enhancements to SQL Server scalability for systems with large memory and processing power. But I do want to mention that some of the improvements with availability improvements will be like replication and backup operations, some areas around always-on availability groups. And then we're going to touch on security capabilities with SQL Server Ledger, encryption enhancements, improvements to dynamic data masking, and more. So this is a storage engine focused session with some mention of other key features in SQL Server 2022. Those that don't know me, my name is David Pless. My previous roles at Microsoft, I was a premier field engineer for well over a decade and was an MCS consultant as a partner consultant before joining Microsoft. For the past 2 years, I've been a senior SQL program manager focusing on Azure virtual machines, performance topics, and now the relational storage engine. So we do have a limited time. I think it's about an hour. It may go a little bit over. So we're going to jump right in. I'm going to have some references at the end as well, where we can explore further. I will be available along with other colleagues in this Q&A. They may jump in as well, depending on the certain topics. So of course, you can reach me on email or Twitter, which is usually the best way to get a hold of me. And one more thing, please put the Q&A in the chat. We're going to do our best to answer any questions you may have. And hopefully you should have some time at the very end to discuss any other topics. All right, so kind of a little bit of a history lesson here. Let's go down memory road a bit. Okay, so with SQL Server 2016, it just runs faster, right? We had a number of developments that drove performance, areas such as improvements in the setup experience and behavioral changes to further optimize TempDB and in-memory OLTP. SQL Server 2016 introduced many foundational capabilities that continue to improve upon the product. Query Store is one of my favorite features. It stores query text and plans and performance metrics at the database level, making it much easier to monitor and troubleshoot, but specifically to migrate your databases and upgrade with greatly reduced risk. Additionally, SQL Server 2016 brought a whole new set of feature capabilities with always encrypted, dynamic data masking, row-level security, so you really get that defense in depth posture that you're looking for. We also introduced Polybase Query Engine that integrates SQL Server with external data with Hadoop and Azure Blob Storage. In 2017, it was all about choice, right? You can run SQL Server on Windows or Linux platforms, including container images with Docker. We started the foundational concept of built-in intelligence with adaptive query processing. This is like the building blocks for intelligent query processing, where simply by making a change at your database compatibility level, like let's say to 140, you can influence query plan behavior. And we introduced batch mode adaptive joins, memory grant feedback, and interleaved execution. We further improved Query Store by adding the ability to automatically tune a workload by identifying query regression and applying the lower cost version of a plan. Then in SQL Server 2019, we further improved upon intelligent query processing by adding batch mode on row store, row mode, memory grant feedback, scalar UDF inlining, and table variable deferred compilation. And all you had to do was change your database compatibility level to 150 on 2019. So we redesigned the database engine recovery process as well with accelerated database recovery. And for security, we added data classification and discovery, making it possible to classify and label sensitive data to help better meet data privacy standards. So now in SQL Server 2022, we've introduced new features across pillars of Azure integration, database and storage engine, analytics, performance with intelligent database, and further extended T-SQL. So I'm going to be touching on just a few of these, and we'll expand on the storage engine topics in this session. So first of all, SQL Server 2022 is Azure-enabled from the start. We can connect and leverage the power of Azure for your SQL Server deployments. For example, you may have heard about the disaster recovery to Azure SQL Managed Instance feature. It provides a way of using SQL Managed Instance as a DR site for SQL Server by leveraging built-in distributed availability group. This greatly saves on the complexity of setting up a disaster recovery site, allowing you to spend a lot less time on setup and management. And you can use this DR site as an Azure SQL managed instance for read scale out scenarios. On the database engine, there's new features and improvements. We have features that help improve performance on large servers with high concurrency needs. Additionally, with MultiRight Replication, you have multiple writable copies of the same database with eventual consistency and automatic conflict resolution. In the area of object storage integrations includes improvements for backup restore with S3 compatible storage systems, and with data virtualization for any data lake. The evolution of Polybase using REST APIs makes it easier for data to stay in its original location and format. So you can virtualize the external data through SQL Server, making it possible to query in place. With the updates to Polybase using REST APIs, we can connect to other data lakes, as well as using the ODBC drivers. There's support for the open row set command and enhancements to T-SQL that includes an enhanced set of functions for working with JSON data in the new time series capabilities. And for intelligent database, we continue to improve query store and intelligent query processing. Query store is on by default, and there are new intelligent query processing abilities, and we have support for query store hits. And finally, we provide extended capabilities built into T-SQL to help power cloud native applications, such as the new JSON data type designed for the ability to query and manipulate JSON data, new T-SQL functions for modern developers, and time series support with T-SQL, similar to the capabilities that we already have for Azure SQL Edge. Now, let's talk about connecting the power of Azure for SQL Server. Previously, I mentioned the disaster recovery capability with Azure SQL Managed Instance. Additionally, the Synapse link for SQL Server provides the ability to capture changes from SQL Server in order to feed Synapse tables for scalable analytics. This really helps us extend the benefits between both platforms. Previously, relying on ETL jobs to position data from on-prem to Synapse, ETL routines are powerful, but they must be developed and maintained, and there's always some degree of built-in lag. Azure Synapse Link automates all of this, providing automatic change feeds that feature the changes within SQL Server and feeds them into Azure Synapse Analytics. Provides data practically at real time for analysis and analytical processing with minimal impact on source systems. So SQL Server 2022 will be able to replicate data to manage instance for disaster recovery and through Synapse Link to power new analytical analysis. So I'm going to talk a little bit about security. We're going to talk about it a tad here, and then we're going to talk about it more towards the end as well. Okay, Azure drives additional security insights and control. Azure Purview gives us the ability to push policies down to SQL Server in order to have better access control and improved management. You can automatically scan your on-prem SQL Server to capture metadata and further classify this data using built-in and custom classifiers. It uses Microsoft Information Protection as well to apply labels to sensitive data and additionally control specific access rights down to SQL Server. Azure Purview policies provide a unified data governance experience to help raise your overall security profile. Additionally, we'll be able to leverage Azure Active Directory to centralize authentication across platforms such as SQL Server and Azure SQL DB using one central identification repository, all managed by Azure Active Directory. And finally, okay, completing the security capabilities, Microsoft Defender helps you gain and correlate insights. Microsoft Defender for SQL is a part of the suite that protects any version of SQL in Azure and SQL Server on-prem. Microsoft Defender helps you focus on what will provide you the most value, quickly raising your security profile and improving your defense in-depth posture. Now, we are going to get into the engine improvements, okay? So on security, I'm going to talk about SQL Server Ledger. We're going to talk about always encrypted enhancements and crypto enhancements. We'll talk about secure encrypted connections and more. With scalability, we'll touch on buffer pool parallel scan, system page latch concurrency enhancements, in-memory OLTP enhancements. And with availability, we're going to talk about MultiRight Replication, last writer wins, accelerated database recovery, cross-platform snapshot backups, Intel QAT backup compression, XML compression, shrink database concurrency improvements, and more. And we have some of the folks on the line here that support and are focused on these features. So this is a great time to ask questions and stuff that you may have seen during your experience this week at SQL Path. So I'm going to touch on TempDB really quick. This is something I really want to get into, but let's do a bit of history. Okay. So first, we know TempDB is one of 4 system databases, right? It's incredibly important for SQL Server. You only get one TempDB per SQL Server instance, and TempDB generally has a high use. It's used by every database for temporary storage. So for example, TempDB can be used for user objects such as global or local temporary tables and indexes, stored procedures, table variables, table-wide functions and cursors, but we also use TempDB for internal scenarios for like work tables that store intermediate results for SQL spools and sorts. There's also hash joins and aggregate operations and a lot more that uses TempDB. That means for every database workload you add, TempDB is carrying more weight. So it's important to get SQL Server TempDB as optimal as possible. But we've had best practices going back many years to improve TempDB performance using multiple files, making sure everything's the same size and uniform. We had trace flags to help with this and to avoid allocation contention. And we talk about TempDB placement being important. We went on the fastest storage possible. But even with the best practices being applied, and we'll have a discussion on this, but to make sure that we are all on target for these best practices, we strongly recommend monitoring TempDB using system OS waiting tasks and in older versions of SQL, and in 2019 using the function page res cracker to give additional details helpful for troubleshooting. I guess the important point is that SQL Server has improved TempDB in every release, and SQL Server 2022 is no exception. So here we're going to get into, now that we've set the stage, some of these improvements. So in 2016, SQL Server, in 2016, the setup itself addressed many of our best practices that I was kind of alluding to. So we do this rather than having the DBAs have to correct these scenarios afterwards. There were important improvements such as temporary tables and table variables being cached to allow operations that drop and create temporary objects to run quicker and reduce page allocation and metadata contention. There was also the multiple TempDB data files. They all auto-grow all at the same time in the same amount. Use uniformed extents over mixed extents. That helps reduce SGAM contention. So what this means is you don't need 11.17 and 11.18 anymore. If you use it, it just essentially gets ignored. In SQL Server 2017, we increased the allowance of the initial TempDB size to 256 gigs per file, and we added the sysdm tran version store space usage to track version store usage per database. In 2019, we added the memory optimized TempDB metadata capability. This is an opt-in scenario, and we eliminated most PFS contention with concurrent PFS updates. Okay, so we brought new installation improvements to the Linux platform as well. There's certainly more to discuss here. I mean, Pam Lahoud has an entire session on TempDB, right? So there's certainly more, but these are the highlights up to 2019. Here's what we've added though. Okay, so in SQL Server 2022, we are addressing yet another common area of contention by introducing concurrent GAM updates. Under higher concurrent workloads, you can witness GAM contention with many different threads that want to allocate or deallocate extents represented on the same GAM page. This is because the updates are serialized and each thread needs to first wait for another thread to release the update latch held on the GAM page, and then they themselves need to obtain the same type of latch while they make their updates to the GAM page. Now, because of this contention, throughput can be decreased, and workloads that require many updates to the GAM page will take longer to complete, while not all the machine's CPU will be utilized. This is due to that workload volume that you'll see in this situation, the use of repetitive create and drop operations, and everybody's seen this, right? Table variables, work tables associated with cursors, order bys, group bys, and any work files that are associated with hash plans. The concurrent GAM update feature in SQL Server 2022 avoids this type of contention. And it's one of the major areas of TempDB contention that has been addressed in SQL Server. So the previous TempDB improvements shown on the slide, okay, along with the concurrent GAM updates, further improves the performance of workloads that tend to suffer, that is, with general contention. So with GAM being addressed, customer workloads will be more scalable and should have better throughput. So these allocation bottlenecks have largely been erased in SQL Server 2022. And one more point, I know I'm focusing on TempDB here, but all user databases benefit from removing this type of contention. So I feels like a good time for a demo. All right, so let us take a look. I'm going to bring my 2019 machine here, okay? Now, I have a monitoring agent that's going on. This machine is an E-series machine, okay? It has, this E-series machine has 8 virtual cores. We're following all the TempDB best practices. It is a marketplace image. And what I'm going to do is run something that in particular is going to make TempDB scream a little bit. Now, that being said, I am running a PowerShell script right here, okay? And this is streaming some metrics from that function page res cracker. And I'm also grabbing this TempDB history here. I'm grabbing stuff from SystemOS waiting task for history. So real time and history, okay? All right, so let me run this load. And what I'm going to do is, this is the query that I was telling you about that will give you some insights of what's going on. And I'm going to just run it and see what I see. Nothing yet. A little bit of contention on the GAM page. Nothing. Wow, there we go. Now let's do the exact same thing on this identical VM. The only difference is I have SQL Server 2022. I'm going to run this workload. It's also doing that streaming, by the way. And I'm going to see if I see any contention. If I do see contention, I expect it to be sysobjects related, because I have not opted in for the in-memory OLTP hackathon improvement for TempDB. I have not done that. I'm not seeing anything. So why don't we take a look at the speedometer, if you will, comparison between these two. This is SQL Server 2022. This is not broken. It's just not getting any contention. I've had 120 points of contention. These were all sys metadata related. My longest wait was 238 milliseconds. This is what we're seeing over here on the 2019 environment. I've had 71,000 points of GAM contention. I've dug through it. It's primarily GAM contention and the occasional in-memory OLTP scenario that could have been addressed had I opted in for that. But I wanted to not pollute this demo. I only wanted to focus on the GAM scenario. Almost 700 milliseconds of a wait. And this is what we're going to see versus this experience in SQL Server 2022. So just one more point of contention that has been addressed, and really happy to see that we're able to address something like this. So we'll be kind of blogging about this a little more, discussing this further, and yeah, if you are suffering from this type of contention in your environment, highly recommend evaluating SQL Server 2022. Okay, I'll move this stuff over again and get back to some slides, because there's a lot of content I want to cover. So I want to dig into this stuff. Okay, there's another one. Let's talk about shrink database with low priority. Speaking in terms of contention, as a practice, it's like we generally don't recommend, I should say it that way, shrinking database files, because databases usually reclaim the space on general usage. However, there are many customers that regularly need to shrink their database files, especially after regular cleanup operations. Post-archival projects, this could be due to localized ETL or temporary reporting objects. There are also customer databases that are application created, right? So applications that create databases per user or per customer may use like a model or a template with some sort of operation that creates these objects. And it's definitely a common case for hosted environments, which all can drive database space. So it's often stated otherwise, but storage is not cheap, okay? And with the increasing amount of data that needs to be kept for regulatory compliance and other scenarios, customers are always looking for ways that they can manage to reduce their storage footprint. Unfortunately, in 2019 and in previous versions of SQL Server, the shrink database command can lead to blocking and lock weights, especially with activities such as managing indexes on any busy active SQL environment. So as a result, customers have had to wait and schedule their shrink database and database file maintenance operations to after hours, as long as running reader operations essentially made it impossible to shrink data files during business hours. So the shrink database wait at low priority feature addresses this problem by improving shrinking when using this mode. This allows readers needing a schema stability lock to not be blocked by the waiting shrink command. Using shrink database with wait at low priority does not affect customer workloads. The only expense is the delay of the database shrink operation. So if you're in that situation, this is a great feature for you. Another one I really like too, especially for if you're using XML, you're using XML, right? So the XML data type was introduced in 2005, and as a result, XML data type has become a common data type that's used to store unstructured data in SQL Server. The challenge, however, is when customers rely on this data type, they often store very large amounts of this data. Think of like banking, legal, healthcare, legal especially, all tend to store XML data for longer timeframes, driving up capacity and increasing customer storage costs. Data compression option in previous versions of SQL Server did not help with compressing XML data types, as they were stored off-row, as data compression only operated on in-row pages. So in SQL Server 2022, the XML compression will allow customers to reduce their storage footprint without any driver updates or any changes to your application. The primary intent of this improvement is to achieve space capacity for the XML data type, though there may be some I/O performance improvements for some workloads. Okay, so we do have a demo, and I want to show you all this. Okay, so here's what I did. First of all, I blew up the person.person table. I created 2 copies, person big XML copy, and then person big XML copy. And I put some indexes on it, XML indexes. And querying sys.xml indexes, I have these indexes shown here, okay? 5 for each. Okay, so then what I did is just got some counts to show me there's no trickery. It's the same. They're identical. And then just do a comparison of using SP space used. Okay. So this is what we have. What is that? Roughly 8 gigs reserved, 3 gigs of data, 5 gigs of index size. Okay. For person big XML copy and then person big XML copy compressed. I haven't compressed anything yet, but I will. And in the next step, what I did is I did an alter table repo partition all with XML compression on. Now, you may like, well, wait a second. What about in-row? What about page and page compression? Like that hasn't been done. I wanted to isolate XML compression, and I'm also doing it at the table level first, not the indexes. Okay. Now, what I did is I created a stored procedure just called SP space use 2. It's essentially just a wrapper, and what I'm doing is flattening the data, removing kilobytes, trimming that out so I can graph it. So here is the graph of this in Data Studio, and you see that 8,075 megabytes for after the compression. This is the savings I got, right? So I went from 8,075 to 6,783. I went from 2,973 to 1,683. XML is the same. I'm sorry, the index size is the same. Okay, so great, right? I've got some storage improvement. By the way, I think that ran for the 2 million some odd rows I hear. I think it was like 25 seconds or something. But now what I did is I'm going to revisit and go after the indexes. And in this case, you know, I redid this here, right? I ran this again, but really I'm going after these 5 indexes, okay? And only with XML compression. Now, when I use that custom stored procedure I created, take a look at the savings now. So I went from 8,075 megs to 3,400. It's quite a bit. It's quite a bit of savings. And it all came from the index compression, going from 5,098 megs to 1,717. That's pretty good. What's interesting, and this is going to be depending on the workload. So I did a just query between the two, and this is just, you know, doing a query and just give me everybody that doesn't have a bachelor's degree, okay? And I'm just taking a look at IO. This is what we saw from a savings perspective. Logical reads, this is the improvement, okay? Which gives us a query cost estimate improvement. If I get down to the bottom, 64 versus 36%. Now, that being said, the primary use case is capacity savings. But for certain workloads, you may see performance improvement, especially in terms of IO. Really, really like this feature, especially for customers that are using a lot of XML data. I think you'll find it beneficial. Okay. All right. So we've covered most of the other stuff. I want to talk a little bit about some of the other capabilities, like accelerated database recovery. That was introduced in 2019 and designed to improve database recovery by redesigning the SQL database engine recovery process, especially useful environments that have long-running transactions. What this feature does is it achieves faster database recovery by versioning all of the physical modifications and only undoing the logical operations, which can be done almost instantly. So a persisted version store is used to persist row versions generated to support versioning in ADR. Now, while this technology improved database recovery for most environments, databases that were really large, or especially those with high patterns of updates and deletes, may have some scalability challenges. In SQL Server 2022, instead of a single thread used for cleanup operations per instance, we have a thread per database, which will greatly accelerate the cleanup process, especially on large systems. We also have improvements that have been made to improve concurrency, reduce the capacity need for the persisted version store, and improve telemetry to make it easier to troubleshoot. With the buffer pool parallel scan feature, this is a new feature that improves performance of the buffer pool scan operations on large memory machines. Like think M series level virtual machines. By utilizing the number of multiple cores, customers that run SQL Server may see upwards of 20 times faster executions, depending on the scenarios. What operations? Think of like creating a new database, backup restore, always on a failover, file drops, DBCC CheckDB operations, internal operations such as checkpoint. All this is going to improve with this buffer pool parallel scan. So as a general scenario, customers have just kind of witnessed, like, this just seems to run faster for those operations. General improvement in performance. For in-memory OLTP, there's an addition of a new stored procedure for manual cleanup and improvements for overall performance, scalability, and better telemetry for troubleshooting. And last but certainly not least in this area, resumable add constraint. This feature is going to allow resumable operations for the T-SQL command alter table add constraint, which is used when adding a primary or unique key. Currently, this operation can be executed online. However, it may take hours to complete on a very large table. When you typically run alter table add constraint, it can consume a lot of resources and it, in rare circumstances, fail to complete. Allowing the benefit to pause during a maintenance window or restart from where it was interrupted without having to restart from the beginning is a powerful feature, especially for large mission critical environments. All right, so let's talk about availability. Getting into an area that's dear to the heart of Brian Carrig, who is very close to this feature. So let's talk about our availability discussion and touch on Intel Quick Assist technology. That's a tongue twister for me, apparently. So this is a compression technology that integrates hardware acceleration of compute-intensive workloads on Intel platforms. Using Intel Quick Assist improves performance across applications, including symmetric encryption, authentication, asymmetric encryption, digital signatures, and lossless data compression. You can enable hardware offloading at the server level by just doing an alter server configuration, and to set hardware offload to on, which is disabled in a similar way. You'll see this command on the screen here. This is how you do it. A server restart is required for the setting to be enabled. Now, after you do this, after a successful restart, you could then run select server property command to verify that the QAT assemblies have been loaded and are available for SQL Server 2022 to use. The output of this function is either going to be a 1 or a 0. 1, it's been successfully enabled, or 0 means it's not available. If the feature is not available, then you would, of course, go to your SQL or Windows log to troubleshoot, just to see, why maybe the device drivers, the QAT software libraries weren't available. But that's, just from a troubleshooting perspective. Now, once you verify the QAT feature is on, you can either run a backup script manually or schedule your backup statement. In order to back up a database with QAT compression, you would simply run a regular backup database statement, but append the statement with compression and state that QAT deflate is being leveraged for the compression algorithm. If you do this without doing the previous steps, you would see an error get surfaced. If you want to, especially if you do a compare and contrast, or if you want to use the previous for whatever reason, you can either just do it without, like you've always done, and just say with compression, or you can specify MS Express, which is the current or at previous compression that we used. All right, let's talk about MultiRight Replication. This is an area Kevin Farley knows quite a bit about, so we'll talk about this here. We have been using transactional replication in the well-established, publisher model, right? Publisher, distributor, subscriber for many years to distribute out copies of data from the source, data from tables, parts of tables for any number of reasons. We may be using replication as a part of a application framework. It could be used for reporting, offloading to data marts, and more. So subscribers could be in any location or may be leveraging peer-to-peer replication in order to establish high availability or disaster recovery. Peer-to-peer replication is built off of this transactional model to provide scale out and high availability by maintaining copies of data across server instances that we call nodes. Now, prior to SQL Server 2022, with peer-to-peer transactional replication, each peer is assigned an originator ID. When there's a conflict with multiple peers updating the same row within a small window, the peer with the highest ID would win, meaning the change made by that replica would be the one that would persist across all replicas. This may not be the desired outcome that you want, leading to unwanted updates propagating across the peer-to-peer deployment. In SQL Server 2022, with when configured with the new last writer wins conflict resolution, we record a timestamp for each update in a hidden column that's added to the part of the table as part of the subscription. When the conflict is detected, we choose the most recent update, in other words, the last writer, to be the value that is persisted on all the replicas instead of the one with the highest ID. So if you see the example shown, consider that we have 2 users attempting to update a column, the same data. At time T0, the replica with ID 2 is trying to set row 1 column A to 45. Okay. At time T1, the replica with ID 2 is trying to set row 1, column A to 23. What's the final value? Well, prior to SQL Server 2022, the update from replica 2 would always win, as its ID is the highest. Now, in SQL Server 2022, with last writer wins, the update from replica 1 made at time T1 is persisted as this is the most recent update. So now we've better control over this behavior, delivering better outcomes, and especially in frequently used peer-to-peer deployments. Okay. So there's plenty more. As Pedro said earlier today, we already touched on MultiRight Replication and talked about shrink database with low priority. We talked about Intel QAT backup compression. What about cross-platform snapshot backups? We're going to be able to perform snapshot backups on Linux and Windows platforms. This is an improved method to coordinate snapshot backups without leveraging VDI or the SQL Server Writer service. With parallel redo, we've made adjustments to make more efficient use of execution threads, leading to faster redo performance and getting better utilization of CPU resources. So this will help you when starting up and restarting a database and making failovers faster and helping availability group deployments in general reduce lag and just keep up better. And for the improved throughput for distributed availability groups, we now use multiple parallel data connections to help speed up replication across a distributed availability group deployment. Now, I promised I would do this, right? So now we're getting into security. We're going to finish off on this topic. So let's talk about SQL Server Ledger. It's important to know that SQL Server Ledger is already available for Azure SQL Database, and I recommend using it. It's like a tamper warning for your data, all managed transparently without any application changes. The feature gives you the ability to cryptographically attest to other parties, like think in terms of like maybe an auditor, that your data has not been tampered with. And SQL Server Ledger preserves historical data. So if a row is updated, the previous value is maintained and protected in a history table. The historical data is stored in a relational format to support queries for auditing and forensics. Now, this works by cryptographically hashing each transaction that the database receives, and the hash function then uses the value of the transaction along with the hash of the previous transaction as an input to this hash function. The function cryptographically links all the transactions together like a blockchain, providing digital trust, especially valuable in multi-party systems, especially with data-sensitive organizations. You think healthcare, financial, government, legal, which all tend to have the need to prove that their data is in fact intact and free from tampering. The SQL Server Ledger is a great solution to establish digital trust in your environment. And we're just like kind of walking through an example here. So let's say Bank A issues a transaction to update the amount of liquidity available for a partner banks to source. Okay. Now the updated rows are copied to a history table to preserve their historical values. A ledger view is created to show the chronicle of the data over time. The data is cryptographically protected in the database ledger, which are system tables that use blockchain data structures. And the cryptographic proofs of the database, called database digests, are then pushed to a trusted storage location to ensure that they cannot be tampered with. The banking regulatory authority can then verify that the ledger has not been tampered with by running a verification process, which references the database digests stored in that tamper-proof storage and compares them to the real-time calculated hashes in the database. If the hashes of the digest do not match the computed hashes in the database at the time of verification, we know a tampering event has occurred. Really powerful feature to just ensure you have digital trust. I highly recommend looking into it further. And if someone wants to drop the link to SQL Server Ledger so you can dig in more, please feel free to do that. I would appreciate it. Let's talk about Azure AD authentication, so simple, but yet so powerful. And let's talk a bit about why. Now, first of all, Azure Active Directory authentication is already available for Azure SQL Database, Managed Instance, and Synapse Analytics. The basic concept is that you can connect to Azure SQL and SQL Server 2022 using identities in Azure Active Directory. But it's not a minor capability, as I've said. It's important for this capability to be available to centralize authority using the most secure method in the industry that keeps improving with new features. This is, of course, Active Directory. So Azure Active Directory authentication unifies the authority mechanism across platforms such as SQL Server and Azure SQL Database using one central identification repository created advantage by Azure Active Directory. Now, this does require a new admin called the Azure Active Directory admin that is set up from the Azure Portal Blade. And the implementation supports some key scenarios. Username and password, of course, integrated with support for Windows authentication in case Windows domain is synchronized with Azure Active Directory. Token-based authentication. And to me, the really important one that I don't want you to miss, multi-factor authentication support. Okay, so to me, this is one of the most important scenarios, multi-factor authentication provided by Azure Active Directory for conditional access. So if you haven't heard the term before, but don't know, you may have heard it and not know what it means, you can provide a method in addition to just like your ID and password. Just ID and password, that's single form, right? So you need an authentication challenge to some other device, maybe such as a mobile phone. So it really comes down to this. This is the way multi-factor authentication works. Something you know, like a password, something that you have with you. It could be like a trusted device, a secure mobile device, which we certainly use in Microsoft, or like a hardware key, or something that you are, or something that is of you, like biometrics, like a fingerprint or a facial scan. Now, it may not seem like this is going to be a huge benefit, but with multi-factor authentication, seriously, this alone will help you protect your users from 99.9% of all cyber security attacks. Most importantly, through adding Azure Active Directory support, this moves us further away from relying on SQL authentication and removing storing passwords in a database. We want our passwords stored in Active Directory domains, and now in Azure Active Directory, it's far more secure for any hybrid environment. Okay. All right, let's talk about Azure Purview labels. Okay, so again, this is already available in Azure SQL Database and Synapse Analytics. And again, drop a link if on any further information for folks. SQL Server 2022 can be governed by Azure Purview. This includes having the possibility to create policies that define who, in other words, which Azure Active Directory account has which permissions on which resource. This could be a resource such as a table or view. The policy can then be published to a SQL Server instance or an individual database. Now, it could also be published to an entire, let's say, resource group or even a subscription. It's going to be like hundreds of SQL servers and databases all at once, right? So that would be probably the most effective and recommended approach. What's interesting is it can also apply to other data services such as Cosmos DB. So in the example shown here, we're applying this data reader policy to a group, and let's call it a group data scientist. It's an Azure Active Directory group, which is being applied to Arc-enabled SQL Server in this example, Managed Instance, Azure SQL Database, Cosmos DB, and SQL Server machines as well. So you can think of Azure Purview as a unified data governance and management service. So when integrated with SQL Server 2022, this is going to give you even greater data discovery and just a general security awareness through this approach. Now, this obviously there's so much more, and look at all the security stuff. I feel like I need multiple slides to cover this, right? We talked about Ledger, we talked about Azure AD authentication. There's also always encrypted with secure enclaves. There's support for new query patterns, including sorting, order by, join, and group by on encrypted columns using enclaves and other performance improvements. We have access control for SQL Server with policies in Azure Purview. We touched on that a moment ago, but we also have crypto enhancements. We've enhanced the default cryptography in SQL Server to exceed industry standards and further protect customers' confidential data. with new granular permissions and roles. These are permissions to help implement the principle of least privilege, which is crucial for defense in-depth approaches. And additionally, ownership chaining will be covered by a new permission. One of the things that now, by the way, the next one I'm covering here is also available in Azure SQL databases, of granular permissions for dynamic data masking. That'll be brought to SQL Server 2022. We'll have the ability to grant and deny unmasked permission at the schema level, the table level, the column level, providing more granular way to control and limit unauthorized access to SQL assets and improve data security management. Connection encryption enhancements with a new TDS protocol. So we're moving from the negotiated to strict encryption established by the connection stream. So the result is support for TLS 1.3 with the TDS message stream completely wrapped in TLS, making the user specify the certificate that they will trust. Of course, we talked about this earlier, Microsoft Defender for SQL that detects and raises alerts. We talked about this earlier, raising alerts for suspicious activities and detecting vulnerabilities using the power of Azure. And there's also some Linux security enhancements as well. So we've added the Active Directory authentication for Linux built in. We make setup and configuration simpler. We also improved machine key security for SQL to protect TD-enabled databases from Linux admins. And finally, we allow admins to use a custom location for machine keys to improve security for SQL Server. Now, I'm right at the hour. There's a lot. I know there's a whole lot I just covered. I know my colleagues have probably dropped a link or two and given some information here. Additional information that I'd love for you to have. A lot of the SQL Server 2022, definitely watch that Microsoft Mechanics video. There's information, this blog has got quite a bit of information. If you're looking for the EAP information, that link is there as well. Kendall Van Dyke, I think, covered that quite a bit this week. So definitely a good thing to look at if you're looking at evaluating SQL Server 2022, where, which is really intended, this program is intended for customers who are going to be able to work directly with engineering. Learn more at SQL Pass with the AKA MS Learn at Pass. There's a ton of work that has been done, Bob Ward and team in the data demos, the IQP demos, and the 2019 notebooks. Go there. It's filled with information. The SQL Workshops link at the bottom. I mean, there is so much there. It's a ton of useful information. And of course, Data Exposed, which I absolutely love. Definitely recommend going to the Data Exposed series and seeing what they do. They just cover a lot of great stuff. Again, that link is here, aka MS Learn at Pass. Just continue your journey. On Microsoft Learn, there's a lot of great content. If you enjoyed the session, again, please give us your feedback. We like to hear, demos are always good. So I wanted to fit some in there. I wanted to give as much information as possible. I know this was packed full of info. Hopefully y'all appreciate that, and I appreciate my colleagues being here to help further discussion and answer your questions. And if you have anything else, just please feel free to reach out. I should have put my email address there as well. It's the same, dpless@microsoft.com. There's not many pluses in the world, so I got to grab that. So hit me up on Twitter @dplus, and there's the link to the SQL Server team. And thank you so much for joining. I hope you had a great week. And any parting words from the team here? Anything that y'all wanted to touch on that I may have brushed over too quickly? Anything? Otherwise, have a great weekend, y'all.
So Dave, there's a question just came in.
Sure.
I'm asking it here because I think we might Pigeonhole might shut down shortly.
Okay.
Any change in the encoding of the error log files?
I am not sure about that one. I would have to reach out to the security team on that particular question. Brian, if you don't mind, can Can you ask the person that reached out on that one to contact us directly, and I can see, I can ask that question. I don't know the answer to that one. It's a good question there. Anything else? All right, I'm going to take that as a no. Everyone have a great weekend. Be safe out there, and let us know if you have any questions on the other side. Take care. Thank you, everybody.